Hi, my name is Trina Mata, and I'm Director of Circular Ventures at the Recycling Partnership. Today, I'm going to share with you some research the partnership conducted on behalf of some of our funders. This research looks at the types of packaging that could serve as alternatives to using expanded polystyrene foam packaging, otherwise known as EPS. This presentation summarizes the results of our research and our recommendations. Today, we'll talk a little bit about the scope of work for this research, the different types of alternative packaging we looked at, a handful of case studies of companies that have already shifted some of their packaging away from EPS, and the recommended actions that the partnership has for any company that is seeking alternatives to expanded polystyrene. The goal of this work was to identify suitable alternatives for expanded polystyrene packaging. To do this, the partnership and our consultants first identified existing uses of expanded polystyrene, then looked at 13 different alternative packaging types. We examined the various attributes of those alternatives, including their recyclability and how available they are. We also examined how other companies have moved away from EPS. While this project included interviews with experts and desktop research, it did not include any MRF testing of these alternatives. Not all of these alternatives are considered commonly recyclable today, and so MRF testing would be recommended for companies that want to try to move to one of those alternatives and also want that alternative to be recyclable. The partnership and our consultants identified 13 possible EPS alternatives. All 13 are listed here, along with the use of EPS packaging that they could potentially replace. These alternatives range from plastic to fiber to other types of packaging. For the detailed research of this project, we looked in detail at 7 of those 13 alternative types. The 7 we looked at were expanded polyethylene, expanded polypropylene, plastic thermoforms of varying resins, plastic air pillows or air cushions, molded fiber packaging, Kraft paper and folded or glued corrugated cardboard inserts, and bio-based foams. So while we felt like these 7 were the most likely alternatives to EPS, there are other options that might be suitable depending on your specific needs. For these 7, we looked at them using desktop research, informational interviews with manufacturers, and also the Recycling Partnership's pathway to circularity. Here's a little bit more information on the partnership's pathway to circularity. This is a framework for helping to understand the recyclability of different packaging types. The framework looks at the different pieces of the recycling system and assesses how a specific packaging type fares in each piece. This includes the packaging fate building block, which helps us understand whether end markets are there that want to buy the material, whether it will get consumed in the marketplace, whether it fits into an existing bale at the MRF, and whether local governments offer collection of it to their residents. The capture journey building block of pathway looks at whether or not a package can successfully sort at a MRF. The design for circularity building block focuses on whether design guides are available for that packaging type and whether end markets have support. Packaging prevalence is an understanding of whether there's a sufficient amount of that packaging type in the recycling stream to make it economical to recover. If you only have a little bit of a certain package, the MRF can't hold on to it for months on end while more comes through the system. This building block also looks at packaging that is very similar and can cause confusion. So if you have 2 packages that look exactly alike, one of them is recyclable and one of them is not, that could cause confusion both for MRFs or consumers. The last building block, MRF and community adoption, focuses on whether consumers, communities, and MRFs know that the packaging type is recyclable and then accept it in their facilities. If all of these building blocks are not met, we consider that package to not be recyclable. And for each of the 7 most likely alternatives to EPS packaging, we assess recyclability using this framework. So diving into these 7 alternatives, the first one we looked at is expanded polyethylene. This is similar to EPS in that it's sort of foamed, and so it has some characteristics that make it functionally similar to EPS. It's lightweight and it performs in a similar way. However, you can also use less material for EPE than you can for EPS to reach the same or even more protection level. Unlike EPS, expanded polyethylene does not contain any styrene. However, one of the drawbacks to using expanded PE is that its fate at a MRF is currently unknown. Depending on its size, it might sort into different parts of the MRF and end up in different bales. If it were about the size of an egg carton, for example, it might end up with other plastic containers, but it could also end up jamming screening equipment at the MRF. If it were a large piece of expanded PE, we might expect it to end up with bulky rigids. If it did end up with bulky rigids, that would require the MRF to spend more on manual labor and therefore add cost to the MRF. If it doesn't end up in either of those two places, the most likely place it would end up is MRF residue, which ends up in a landfill. If expanded PE were to make it through the MRF and to a reclaimer, not all reclaimers would want it. Bulky rigid reclaimers typically accept high-density polyethylene and polypropylene, but they wouldn't want expanded low-density polyethylene. Foam reclaimers might want expanded polyethylene, but most MRFs don't create a bale for EPE or film, so it would be difficult to get it to foam reclaimers. Supply could also be a challenge for expanded polyethylene. There are currently fluctuations in its availability, although there is capacity to produce more depending on how much demand there is. It's also more expensive than expanded polystyrene. EPE cannot be used to form cavities in the same way that EPS does, and it could also be confused for EPS by either consumers or a MRF. This is a look at how EPE fares in the pathway to circularity building blocks. As you can see, there are a lot of areas marked with a red X where expanded polyethylene does not pass. There will be a lot of steps to take before EPE can be considered recyclable. If we take a look at our next alternative, it's expanded polypropylene. So again, it's somewhat similar to EPE and EPS. It's lightweight and like EPE, can use less material to reach the same level of protection as expanded polystyrene. Its performance is similar to EPS. Unlike EPS, it can be designed for reuse. In a MRF setting, expanded polypropylene would act really similarly to EPE. It may or may not sort into a bale of polypropylene. If it did make its way to a polypropylene bale, polypropylene reclaimers would be happy to take it. However, whether it would sort correctly is unknown, and to find that out, likely MRF testing would be necessary. Supplies of EPE are expensive. They can be as much as 3 to 4 times as much as EPS. Here's a look at EPE on the pathway to circularity. There are more check marks here than we saw for EPE, but there are still some areas of concern, and further testing would be needed to understand how to make EPP recyclable. For both EPE and expanded polypropylene, if there was interest in understanding the recyclability of these packaging types, the partnership recommends conducting MRF trials to learn how these materials sort in a MRF as a first step towards reaching recyclability. In addition to that, we would also suggest interviewing reclaimers to learn whether the material would be accepted. One way to approach this type of research would be to consider forming a group of companies interested in understanding the recyclability of EPE and EPP. What comes out of that research could lead to next steps for moving further along the path towards recyclability for EPE and EPP. Our next alternative is plastic thermoforms, commonly made out of PET, but also other resins are used. This is a lightweight package. It's easy to cut, it's easy to mold and shape to the desired purpose. It can be used for fragile products or for meat trays. Currently, PET thermoforms are not considered widely recyclable according to FTC standards. However, the Recycling Partnership does have a PET coalition, and part of that work of the coalition will be on PET recyclability. So please let us know if you'd like more information on the PET coalition. There is wide availability of PET thermoforms, and most suppliers are able to increase their throughput. This is a product that's more expensive than EPS, especially depending on the use, but likely not as expensive as EPE or EPP. PET thermoforms face a different set of challenges on the pathway to circularity than the alternatives we've talked about so far. PET thermoforms would sort at a MRF, they would end up in a PET bale. There are design guides available, and there's prevalence in the marketplace. On the flip side, there is a weak demand for the material from end markets. They're looking for PET bottles more often than PET thermoforms. And many MRFs and communities don't consider this an acceptable material for recycling. Our next alternative here is plastic air pillows or plastic air cushions. You see these often in boxes from e-commerce. They are used as void fill or to provide stability in packaging. They're lightweight, but on the flip side, they take up a lot of space in a package, which can have an impact on shipping costs. Air pillows are recyclable through store drop-off programs. So we ask that you not put these in your recycling cart, but take them back to grocery stores or other locations that are accepting plastic grocery bags for recycling. The Recycling Partnerships Film and Flexibles Coalition is working on ways to recycle air pillows at the curb, though. Plastic air pillows are widely available. They do require consumers to take that extra step of returning them to the store for recycling. Here's the pathway to circularity building blocks for plastic air pillows. As you can see, there are a lot of red X's for the curbside recycling system and air pillows. This is because they're not currently recyclable at the curb, but as mentioned, there are a group of companies working on this as part of the Recycling Partnerships Film and Flexibles Coalition. Please reach out to me if you'd like more information about that work. And here's just a quick look at what we are doing as part of the Film and Flexibles Coalition to address these challenges. We have pilots designed to better capture film at MRFs and at reclaimers. We're collaborating with APR to help them enhance their design guides for film. And we're talking with end markets. Moving on to our next alternative, this is molded fiber. Molded fiber can be made from mixed paper and newspaper, or even from products like bagasse or bamboo. For food grade applications, manufacturers would use virgin pulp or food grade recycled pulp. Molded fiber is increasingly used for custom molded applications. Molded fiber recyclability is a little tricky. Some communities do not explicitly accept molded fiber by listing it on their websites. They might list mixed paper, and that could include molded fiber, but they don't call out specifically molded fiber. So this makes it really challenging to determine what the access rate of molded fiber packaging is. However, generally it's considered acceptable by mixed paper recycling mills. There is an active molded fiber market, although there are some concerns surrounding the availability to meet demand. The industry is willing to expand, though, if commitments to purchase are made. Molded fiber does have a higher price than EPS packaging. As you can see from this slide, molded fiber passes all of the criteria on the pathway to circularity building blocks. Our next alternative is Kraft paper and folded or glued cardboard. So this is paper that can be used as filler or as protective layers for fragile items. In addition, this category includes cardboard that has been cut out or shaped to fit around a specific item. One downside to this alternative is that you may need labor if you're wrapping individual items in Kraft paper or folded cardboard. Kraft paper and cardboard are both widely recyclable and available. There is a higher cost than EPS depending on the use of the product. Kraft paper and cardboard pass all of the criteria of the pathway to circularity building blocks. They are widely recyclable. Our last alternative is bio-based foam packaging. So this can be used as void fill or for shock absorption. Bio-based foam packaging can be made out of mushrooms, cornstarch, vegetable starch, and other alternatives. Some bio-based foams may have ASTM or BPI certification for compostability, and those that do will fully degrade in large-scale composting facilities. There is currently very low access to curbside composting, however, so it would be challenging to compost these in a home setting. The suppliers spoken with for this research indicated they can increase their throughput if requested. There are a few challenges with using bio-based foam packaging, however. It is not recyclable and would be a contaminant if it entered the recycling system. A study recently by the Sustainable Packaging Coalition noted that 27% of the US population has access to composting, either through curbside or drop-off sources. This includes both municipally provided composting services as well as privately managed systems. This means that not all of those 27% of the US population has automatic access to composting. They would have to request it in some cases and pay for it in some cases. In addition, not all of those composting operations accept compostable packaging. They may be limited to food scraps. The SPC study also found that 11% of the US population has access to composting programs that accept some type of packaging. So bio-based foam packaging is not recyclable, and it would be difficult in most cases to compost it at the curb. As bio-based foam packaging is not designed for recyclability, it does not pass the pathway to circularity building blocks. Interviews with our packaging suppliers were conducted as part of this research. Several noted that they're willing to make changes to their products to help customers achieve sustainability goals. Long-term agreements can help suppliers make adjustments. These suppliers are also available to take on additional customers without any investments in expansion. To summarize this research, there are a number of alternatives available to EPS packaging. Several of these options are recyclable or on a path towards recyclability. All of these alternatives appear to be more expensive than EPS. However, that cost differential could shrink if demand for the product increases. Choosing the right alternative will depend on the application that you need it for. Now I'll review a couple of case studies of companies that have shifted some or all of their packaging away from EPS. Ahold Delhaize has a company-wide initiative to increase recyclability of the products they use, which has led to EPS reduction goals. They created an internal team called the Plastic Center of Excellence that evaluates all of its single-use packaging. Home Depot has taken on a multi-year effort to replace EPS packaging with recyclable materials for some of their private label products. Home Depot eliminated 517,000 cubic feet of EPS foam in 2018 and an additional 19,000 cubic feet in 2019. That equates to about 635,000 pounds or 317 tons of EPS in those 2 years. As one example of their work, Home Depot replaced EPS foam packaging as the protective cushion for their Husky LED work light. They used molded fiber in place of that EPS. This ended up reducing their package size by 25%. Home Depot found that the molded fiber alternative was stronger, resulting in half as many damaged product returns compared to their original EPS packaging. The smaller, lighter package provided other benefits, including improved shipping efficiency and a reduced amount of shelf space needed per package. Another company, Crate & Barrel, has implemented alternatives to EPS for its products to allow for recyclability. They use green wrap paper and air pillows for all the merchandise that is boxed up in their retail stores and in their warehouses. For vendors and suppliers, they set a limit on the amount of EPS that can be used in packaging, and they recommend alternatives to EPS for their suppliers. Dell began transitioning away from EPS in 2009. Their current goal is to make 100% of their packaging and 50% of their products out of recycled content or renewable materials by the year 2030. When Dell started back in 2009, they first switched to a bamboo cushion for their packaging. Today, they use a variety of alternatives in place of EPS, including bamboo-based packaging, mushroom-based packaging, molded fiber, high-density polyethylene, and air pillows. This chart shows the variety of packaging options that Dell uses today. Looking at all of these options, our recommendations to those who have decided to move away from EPS is to start by looking at the packaging you use currently. Think about what you use EPS for and what performance characteristics you need in an alternative. There may be an option to replace those that is already considered recyclable. If not, work with others on the supply chain by funding and participating in collaborative initiatives that are helping to move those alternatives that are not yet recyclable closer to recyclability. The Recycling Partnerships Film and Flexibles Coalition and our PET Coalition are two examples. Keep in mind that currently most or all alternatives related to EPS are going to be more expensive than EPS, but as time goes on, that may change. Lastly, we recommend that you join the US Plastics Pact to work collaboratively on addressing the use of plastics. Thanks so much for your time.